So we are in our last new notes of the entire year, and we're going to do 4 examples of solids that are created by revolving a shape. So our first example is going to be taking the equation, the square root of x, which is that red line you see, and the x equals 9 and the region R. So you see this region R right in here, and we're going to rotate that around the x-axis. And what do we mean by rotating in here? I'm going to use my little drill. We're going to take our shape and we're going to rotate it. How about that? And what is it doing when it rotates? It's creating a circle there. You see that? So we have that beautiful circle, and it's going to create a 3D solid. And what is the shape of the cross section? In our previous lesson, it was triangles and rectangles and that sort of thing. Well, you can see right here that when I look from the side, I see a big giant circle right there. And what do we see is the radius of that circle? Well, it's the top equation minus the bottom equation. So notice, like, I drew it on the outside function right here. But, you know, if I'm doing it earlier in the shape, the radius would be a little bit smaller. So that's what these red lines right here are drawing. So again, we're going to do the same thing we did before. What's the shape of the cross section? It's a circle. What's the formula for that shape? Well, area, fuzzy wuzzy was a bear. Area is pi r square. And how do you find the length of the radius? Well, it's going to be the top function minus the bottom function. The top function in this case is the square root of x, and the bottom function in this case happens to be the x-axis. So you'll notice that I wrote the red function minus the blue function, which in this case is, or the green function really. It's the red function, the square root of x, minus the green function, which is y equals 0. And so our radius is the square root of x. And do you remember how we do volume? We do volume equals the lower bound to the higher bound, and then we put the shape of the area there, or the area formula of the shape there, pi r squared, and we just found out that the radius is the square root of x. I could have simplified this, by the way. The square root of x squared is x. I could have put the pi on the outside of the integral because it's a constant, but I just chose not to do that. So volume equals from 0 to 9 of pi r squared, and the radius of this shape is from the top function minus the bottom function. So the square root of x, this red shape, minus the bottom function, which was the x-axis, which is y equals 0. So the square root of x minus 0 is my radius. Volume equals the lower bound to the higher bound of pi r squared. Get our answer and move on.